Now we're going to get into the specific special parallelograms. Okay, the first one we're going to talk about is a rhombus. Okay, you should have already written down that a rhombus is a parallelogram with 4 sides congruent. So all the sides are the same. So I'm going to go ahead and mark that in my picture, okay, with these tick marks. All of these are congruent. That's what makes it a rhombus, okay, and the fact that it's a parallelogram. So the opposite sides are parallel. So I'm going to mark those. Now, the diagonals in a rhombus have a couple of additional attributes. All of those that we said about parallelograms are still true because this is a parallelogram. Okay, but we're going to add to it. Okay, so I'm going to draw those diagonals. Okay, the first one that some people may notice just by looking, but again, just based on the looks, you can't always say things because it's not always drawn to scale. Okay, but once you have learned this rule, you will know that this is a 90-degree angle. Where those intersect is always going to create a 90-degree angle in a rhombus. The diagonals are, that word, perpendicular. Okay, again, you need to make sure you know your vocab. Perpendicular means intersect at 90 degrees. Okay, so they're perpendicular. Okay, a lot of people want to say congruent just because they see the blank. These are not congruent. If you look across this rhombus, this is a much longer length than this side. Okay, they're not going to be congruent because the angles are not congruent. Okay, so this diagonal has to stretch farther than this diagonal does. Okay, so do not try and put congruent here. The diagonals of a rhombus are perpendicular and they bisect each other. Okay, that was one that we already had said is true for all parallelograms, so it stays true for rhombuses. Okay, so they are perpendicular and bisect each other. So I'm going to mark this congruent to this, and these congruent. Notice again, I didn't use one tick mark because I already used one for the sides. Okay, the other thing you need to know about the diagonals of a rhombus is what they do to the angles. Okay, so here, each of these angles is actually being bisected. So this is cut in half by the diagonal. Okay, so the diagonals bisect the angles of the rhombus. Okay, we said the opposite angles were congruent, so even if they're bisected, that means all 4 of these would be congruent. Okay, same would hold true for these. I put 2 tick marks, it's bisected, and across from it, opposite angles in a parallelogram are congruent. So all 4 of those angles created will be congruent. Next up is the rectangle. Hopefully y'all are comfortable with rectangles. We know that it's a parallelogram with 4 angles congruent, which means they are all 90 degrees. Okay, so we have opposite sides parallel. That's what makes it a parallelogram, and the 90-degree angles make it a rectangle. Okay, what's special about a rectangle's diagonals? Okay, all of the other attributes of parallelograms still are true. Opposite sides are congruent, consecutive angles are supplementary, and opposite angles are congruent. Okay, but now with the diagonals of a rectangle, this is not 90 degrees like the rhombus. Okay, so they're not perpendicular. Okay, but they do still bisect each other because that was true for all parallelograms. Okay, so here in the second blank, you can put that they bisect each other. Okay, now the other thing you need to know, we'll mark those congruent, is that they are actually equal lengths. Okay, so all of these 4 segments created by this intersection are going to be congruent because the diagonals are congruent. Okay, so you'll be able to use that information to find a lot of your missing sides or perimeters when you're asked questions about rectangles. Okay, the third special parallelogram we're going to talk about is the square. Okay, the square has all four angles congruent, they're 90, and all four sides. It's the product of a rectangle and rhombus. Okay, so a square is a rhombus, a square is a rectangle. Okay, you can think of those in your family tree. The square is the baby, and the rhombus and the rectangle are the mom and dad. Okay, the diagonals of a square then have all of the attributes of the rhombus and rectangle. Okay, which means that they are congruent like the rectangle. They are perpendicular like the rhombus. And they bisect each other like all parallelograms. Alright, now we're going to do a few examples practicing with rectangles, general parallelograms, and squares. Okay, now here in the first example, they tell you that WXYZ is a rectangle. Okay, point V is the intersection of the two diagonals, and they tell you that VY is 15. They want us to find XZ or ZX, so that is the length of this diagonal. Well, we know that in a rectangle, diagonals are bisected and they are congruent. So remember, all four of the segments created by that intersection are going to be the same. So all of those would be 15. So the length from Z all the way to X would be 15 plus 15, which is 30. The length from W to V would just be 15. And they ask us about angle WZY. WZY, so that's this angle here. Well, in a rectangle, what are all four angles? 90 degrees. So this would be 90 degrees. In this next example, it tells us that ABCD is a parallelogram. They give us angle D is 59 and want us to find X, which is a portion of this angle. Okay, this diagonal's splitting it. It's not necessarily in half because they didn't tell us that it's a rhombus or a square, so we don't know that it's half. But these two together will create this entire angle, and we know that in all parallelograms, consecutive angles are supplementary, which means they should add to 180. So I'll take my 180 and subtract 59, and that is going to leave me with 121. Okay, so that's for this entire angle. A portion of it is 98 degrees, so I will subtract that 98 degrees. Okay, that leaves us 23 degrees. Okay, so 23 degrees is angle X. They also ask us to find angle B. Okay, that's this angle here, the top right corner. And we know in parallelograms, opposite angles are congruent. So that would be 59. And then they ask us for DCB. DCB, that's this entire angle. Okay, well we just found that before we took away the 98. It was 121 degrees. The next example asks us to find angle X and angle Y, and they tell us that LMNO is a square. So we know that this entire angle is 90 because all the angles of a square are 90 degrees. And you need to remember that the diagonals are bisecting the angles. So these two angles are congruent to each other. So these two angles would both be 45 degrees because I just took 90 and divided by 2. So X is 45 degrees. Now the diagonals are perpendicular. Okay, you should have written that down. Perpendicular means they create a 90-degree angle. So angle Y would be 90 degrees. Now they ask us what segment LN is congruent to. LN is this diagonal, and in a square the diagonals are congruent to each other. So the other diagonal would be MO or OM. I want to make sure, I think we might have left that off of our rules. If you go back to where you wrote about squares, we said the diagonals are congruent and perpendicular. They bisect each other and the angles. So they bisect each other and they bisect the angles of the square. Make sure you get that in. Should have had one more blank there. Okay? And that's it.